name is Craigory, and in this talk we'll be going over how you can add languages such as .NET, Java, Python, or anything else like that inside of your NX monorepo, even though it's not something that's explicitly supported. First, a little bit about me. My name is Craigory Coppola. I'm a software engineer on the NX core team here at Nrwl, and I'm also the lead developer and maintainer of a community plugin called nx-dotnet, which will let you bring .NET apps inside of NX pretty easily. So first, let's talk a little bit about why you might want to do this. So by bringing any of these technologies inside of NX, you can actually leverage all of the benefits that you get with your JavaScript or TypeScript code in those languages without having to use separate tooling or anything. So that means you can get access to the local or distributed cache, dependency graph analysis, the ability to build what's been affected by your changes, and also take advantage of things like your distributed task execution with NX Cloud. Whenever you're moving to a monorepo, there's also just a chance that you have some legacy code or some other apps that are written in these languages which aren't supported, but you still want them inside of your monorepo. Now, there's several ways you can go about this. So first off, there's a lot of existing community plugins, and there's a pretty good chance that there might be one for what you're looking for. So I'd really recommend starting there. But if there's not, you can always check out Nrwl Workspace Run Commands, which will let you pretty easily adopt any tool as long as you can build it from the command line. And that'll get you pretty far, but if you want to go a little bit further, you can always do things with custom generators and executors. And if you've already done that, the steps to make that a full plugin are pretty simple, and you can get a lot of benefits from that, including the ability to distribute it. So, like I said, starting out, there's a ton of existing community plugins. These include plugins for Vue or Svelte if you're just looking for a front-end tooling that isn't natively supported, or things like Flutter, .NET, Go, Java with Spring, any of those that are actually completely different languages. And they work pretty well, so I'd really recommend checking those out before you dive way too deep into doing something completely custom. But let's say that you were moving C# in and the .NET plugin didn't exist. How would you go about that? So this is where things like Nrwl Workspace Run Commands can come in handy. So Run Commands does exactly what it says. It just runs a command or multiple commands, and you can have it do that in parallel if you need. But what you get with this is the ability to specify a command. So like for .NET, we would use .NET build and where to run that command. So in this case, we have a products API set up, and we can tell it to just operate that .NET build command inside of apps products API. Let's see what migrating to run commands would look like in a real workspace. Okay, so here we have an NX workspace that contains an Angular app and its Cypress tests, as well as a C# API. However, when we look at our workspace.json file here, we can see that currently we only have that Cypress tests and the Angular app set up. So if we were to run an nx graph, for example, we can see that NX only knows about the one application and its end-to-end test. It doesn't know about that C# API right now. So for getting that to work, we can come in here and we can define that new project, and we'll call it a legacy API to match the folder structure. And we can tell it it's inside of apps legacy API. And we can go ahead and start defining a few targets for it. So one thing that we most likely want to be able to do is build our project. So if we're going to define that build executor, we can tell it to use Nrwl Workspace Run Commands. And just like we showed in the slide, we can use .NET build. And we probably want to do that inside of apps/legacy API. So by doing that, if we click here, we can already see that build working. And we can see that it went straight through the regular .NET build workflow. And we can see that up here in our bin folder, we have our build output, since that's how .NET does it by default. But run commands doesn't have to just be used for build. We can easily use it for serve as well. So for an example serve, we can set up our serve executor. And we can see we're still just using run commands. And we're going to use .NET watch run. And I want to do that in apps legacy API. So now, if we run nx serve legacy API, we get the same tooling experience that we get with NX out of the box, but we can have our full swagger and everything that we get with .NET up to and including executing. So from here, if we come back and we update our depth graph, we can see that NX now has full knowledge of this project. So we get our legacy API and our Angular apps in here. And if we select all of them, we can get them there. Now, one of the cool things that we already get with NX is that if we come into our nx.json file and in our modern app, we can add an implicit dependency on that API. So by doing that, whenever we come back to our depth graph, if we focus on our app, we can see it has that dependency on our legacy API, which means that anytime we make a change to our legacy API, it's going to rebuild our modern app. So if part of that build process is something that outputs type definitions or anything like that, we can immediately start seeing those results. By adding a dependency like this, you also can take advantage of target dependencies in NX. So if files from this build are required, such as type definitions, whenever you try to build your modern app, it's going to automatically build your legacy API. So now that we see how that works, what are some of the pros and cons to that? So with run commands, you get really easy to read and modify targets, which means that things like if your .NET build command needs to be changed, pretty much any developer on your team that knows how to build .NET is going to be able to do it without having to know a lot of NX specifics. And it works with common shell syntax, so anybody that's written shell scripts before should be able to implement these targets. And also, if you have any arguments that need to be passed into your .NET build, run commands is going to automatically forward those. Now, on the downsides though, any of these targets, the syntax for them is repeated on every project, which means if you have 50 .NET projects and you need to change the build command, you're going to be changing that 50 times. And also any of those extra arguments aren't going to be validated by NX, so it's possible that you're going to be passing bad data into your custom tooling. So after that, you might want to be able to generate an app from NX just like you would in Angular, Node, or React. This is really the place where custom generators can come in handy, because a lot of tooling doesn't have the sort of code generation properties that we provide. And they're written in TypeScript, and it's something that NX can compile and run on the fly. You define a schema, which is a list of definitions for any of the properties that your schematic takes, and then they can come in and generate your tooling. Now, if your tooling does have code generation, you can just use xxsync and things like that from Node to automatically build out this schematic. So if we were to look at this in a real workspace, you can come back into our workspace. And you can come in here and tell NX to generate a workspace schematic. And we're going to call it .NET API. Okay. And you see we get two files that were created. One is the TypeScript definition, and the other is that schema that we were talking about. When we look at these files, what we can see is the default options, which is a library name. And we can see that it's going to automatically pull that from the arguments that you pass in. So we actually probably want this to be our app name, since we're defining an API generator. and then we get an index file. So by default, NX is going to be just calling through to the node library generator, formatting the file since it's going to update Workspace JSON and stuff like that to make sure that it's not messing up your formatting, and then install any packages that were needed. So since we're not going to be creating a node library, we can remove this line and we can pull in our Workspace generator. So let's go ahead and add our imports. And this is where we can start to see how this works. So since we are using .NET and we can just use .NET New to do our actual code generation, we're going to just create our directory, which is going to be under apps, and it's going to be the name from our schema. And then we're just going to be executing our .NET New Web API command. After that, we need to tell NX about it, so we can use add project configuration. And we're still going to be using our Nrwl run commands. If we wanted to also add a serve target, since this is an API, we can come down here and we can look at our serve executor from our legacy API. We can grab that, come over here, paste it in, and all we need to do is tell it that this working directory is going to be our directory. So what this gets us is that now, if we want to create a new API in C#, we can do nx Workspace Generator .NET API and say my new API. And what we get here is that it's calling through .NET New, and we can see our normal .NET New output. And then it's also updating Workspace JSON and nx-JSON. So when we come back here, we can see that we have my modern app end-to-end, as well as my new API with a build and serve target. And we can see that if we click here, we can already get a working build like we would expect. And when we come back here, we've got a new folder, my new API, with a completed build in it. So what are some pros and cons with our custom generators? When you're using a custom generator, you can really simplify common commands whenever you are calling through to these third-party CLIs. So if there's a bunch of arguments that you would normally pass in to customize your templates or anything like that, you can set them in the Workspace generator to wrap that, and you don't have to worry about people accidentally not passing in the correct properties or anything like that. Additionally, you're working in node syntax, which means that it's really cross-platform as long as you're careful when you're actually executing a child process. You get that schema file, which will validate any options you pass through. So if you're passing something that's not valid, it's going to tell you about it. And if the language that you're working with doesn't provide some sort of code gen, you can use NX's templating with EJS to implement this pretty easily when it's not something that's supported from your tooling. Now, some of the negatives is that if you are wrapping an existing CLI, dry run's not going to necessarily work out of the box. This is because the NX generators use a custom file tree, and if you're not writing or deleting or anything like that through that file tree, NX doesn't know about it, so it can't roll it back. And this kind of leads into that second con, which NX does use a virtual tree. So if you have file system utilities already written that don't use that tree, you're going to have to modify them a little bit for them to work here. So to see this dry run issue, if we go back into our workspace and we try to run dry run with some other API, we can see that NX knows about the dry run, and it says that dry run made no changes, but since .NET isn't aware of that, we end up still getting my other API here as a folder. So that's a little bit of a bummer. It's not too big of a deal inside of .NET because .NET also supports dry run, so we can always detect dry run and then add a flag like that, but that is something you have to think about. And you can see here, in this generator, we are actually detecting that dry run flag here just by looking at the argv arguments passed in and checking if dry run is one of them. If that's the case, that's when we can append dry run and stuff like that. So after that, we can start trying to address some of the cons that we ran into with run commands. And the major one there really is that if you need to make a change, you're having to make it in each one of those projects, and it would be much easier if you can just specify an executor. So let's see how we can go about writing this. So in this example, we had this .NET plugin package in our dist folder, and that's going to be the first thing we have to get to be able to write a custom executor. So back in our code, to generate a new .NET plugin, we can do nx-dotnet/nx-plugin, and we're just going to call this our .NET plugin. So this generates a few files, and as well as an indent project if we wanted to use it. So the first thing we can do is we can come into our .NET plugin that we just created, which is under libraries, and we can look at what came out. So it gives us a generator, but we're not really going to use that right now. The main thing we want is this executor, and it actually is already called build, so we can just use the files that it already created. And what we want to do is come up here and look at all of the options we get. One thing that's not included out of the box in this is the context object, which is an executor context. But what this gives us is the workspace definition that the executor is being ran in. So we can do something like const project config, project configuration equals context.workspace.projects sub context.project name. And that's going to give us all of the information that we need for being able to build a .NET project. Now, all we need to do to build it is use exec-sync and .NET build, just like we did with run commands. This is something where we're not seeing a ton of benefit right now from using .NET build inside of an executor versus using run commands. But one thing that really is big is the ability to only change it in this one spot instead of having to go through all of your definitions. So we need to remember to set our current working directory, and in this case we can read that right from our project configuration. Now, to actually use this executor, we need to first build our plugin. So we can run nx-build our .NET plugin. And now that that's built, all we have to do is come into any of our executors that are using run commands, and we can change this to now point to /dist/libs/our.NET plugin, because that's where it built to. And when we come in here and look at our dist folder, we can see our .NET plugin here, and we see it has this executors.json file. That's where we can get this name build, and that's what we're going to tell it to use. So we want to use build. These options are no longer valid since we're not using them, so we can just go ahead and remove them completely. And now if we were to run nx-build legacy API, we can see that it did build. Now we didn't see any output here, and that's just because of the way we have our exec-sync set up. If we come back into our executor and we tell it to forward that standard input output to us, we should still see that. So with that change, if we rebuild our executor, we can get that same behavior. But we need to tell it to skip the next cache since the project itself didn't change at all. And that's one of the pain points with doing it this way. But an easy way to make sure that this happens is just to come into nx.json and add an implicit dependency from any project that uses it to your plugin that's in your workspace. So this is where you can have implicit dependencies and do our .NET plugin. So see now, if we were to run nx-build legacy API, we can see that it has a task it depends on, and that task there is to rebuild our plugin. Now that we've seen how to build a custom executor, let's talk a little bit about what the pros of doing that are and what the cons are. So whenever you're doing a custom executor, you get better compatibility across operating systems, and that's because of the way it works with common node syntax. So instead of relying on a shell script or a bunch of commands that are specified in run commands, which they have syntax that may change depending on which command line is running them, you get to use these node APIs, which are consistent whether you're on Linux, Windows, or Mac. Additionally, you get these options that you can validate in a schema file. We didn't take advantage of those in the demo, but similarly to the generator, they give you the ability to reject a command if somebody passes an invalid argument. And you only have to implement them once, so you're not going to be stuck modifying 50 definitions if a change is needed because of a language update or something like that. Now, on the cons, we do have that the project has to be built before it can be ran. We already addressed this a little bit in our demo where we added target dependencies to be able to make sure that happens. And then the other one is that your arguments must be defined in a schema. So that's kind of a double-edged sword, right? You get to be able to easily validate them, but if you're having a plugin that has to support all of the options the CLI tool does, you might end up redefining a lot of them. So an NX plugin really is just a collection of executors and generators that is distributable. But we've also recently exposed some stuff to let them have built-in dependency graph support. And we'll show that a little bit on the next slide. But Workspace generators and executors can get you most of the way there, being able to scaffold apps and take advantage of implicit dependencies. And you get that same schema validation from a full plugin. And you also have run commands, which let you define those executors simply if you're already using an existing CLI or shell script. Now that we've seen how easy it is to get started moving these kinds of projects inside of NX, let's talk about some flaws with the approach we've taken and how those can be worked around in a full plugin. So for this demo, we're going to start going over exactly what issues we are seeing and how those are taken care of in my plugin, nx-dotnet. So right now, if we were to add a reference to our legacy API project that references our new API that we just created, one thing that we see is that the depth graph doesn't actually pick that up. So let's go ahead and do that. Legacy API. We're adding this reference to my new API. Whenever we look at our depth graph now, if we were to focus on that change and look at our legacy API, we can see that it's not tied into that new API at all. And if we select it, it's not referencing anything. So we end up with it being completely off to the side now. Like I mentioned, we can always use implicit dependencies to tie these together. But the other thing we can look at is that the nx-dotnet plugin takes advantage of the project graph API that NX exposes, which will actually let it do that automatically. So if we were to run nxg at nx-dotnet/core init to initialize the plugin, and then come into our nx.json and add a tag to our projects to let nx.net know about them. When we run depth graph again, we can see that that dependency is actually picked up automatically. And this is just one of those things that NX has recently exposed that can really help out with multi-language support. There's a couple other things that are really cool that plugins can help take care of, which is like if you come into your apps folder and you drag in a brand new app, like let's say my other legacy API, for example, and we'll just make that a new web API. We can easily bring that in to NX by using nx.net's import projects feature, which will automatically create those project configurations. And we can see that because if we look back at our depth graph again, we actually end up having my other legacy API in here as well. So that's our full project graph now. So, as we've seen, NX actually exposes quite a lot for being able to work with these languages, despite it not being something that's explicitly supported. If anybody has any questions about any of this, definitely feel free to reach out to me via Twitter or GitHub, but I also actually hang out on the community Slack quite a lot, so I'm also available there. I definitely recommend reaching out on there, even if you just have a general NX question. There's a ton of people there who would love to help. Thanks for your time.